Hello and welcome to this eighth algorithm selection and development lecture in this course, Master in Artificial Intelligence. So in this we will talk about hyperparameters and one of the hyperparameters that is learning rate in the gradient descent. So hyperparameter tuning involves using hyperparameters. Those are the parameters that are set prior to model training and control the learning process of the model. Now, what are the examples of such hyperparameters? One of them is this learning rate in gradient descent that we will cover in this lecture in greater detail. Second is the number of hidden layers in the neural network, which we will talk about in the next one. And then there is the regularization strength that we will cover in the subsequent lecture. So, what is the learning rate in gradient descent? What exactly is this? Any thoughts? Anything that you know? So the learning rate is the rate that determines the step size taken during the gradient descent optimization process of the model learning, right? Right. So that's a great detail. But then, what the hell is gradient descent optimization process? Let's take a look at that and let's understand this gradient descent optimization process. Now, gradient descent is an optimization algorithm. It's an algorithm that optimizes, that is used to minimize the loss or the cost function of a machine learning model. What are the errors? So it minimizes the errors in the learning model, machine learning model. And it works by iteratively updating the parameters of the model in the direction of the steepest descent of the loss function or the cost function. Now, so that's the principle. You get an idea? Let's take a look at this. How does this gradient descent optimization process works? It starts by initialization. You start by initializing the parameters of the model as you see here. You start with the initial weight as indicated based on your best informed decision, weights and biases, or two randomly or predefined values. So you have either predefined values or you take randomly at a starting point. So you have a starting point. Then what you do is you calculate the gradient of the loss function or the cost function, right? Which is seen by the dotted line here that you see here. With respect to each parameter in the model. So you take one parameter at a time and for each parameter you calculate this gradient. This gradient indicates the direction of the steepest increase of the loss function. To minimize the losses or errors or cost function, we want to move in the direction opposite to the gradient. Make sense? Because ultimate objective is to reach that minimum cost and minimum error function, right? Then what you do is you update the parameters. You update the parameters of the model by taking a small step in the direction opposite to the gradient. The size of the step is determined by the learning rate hyperparameter. That's where you set this learning rate hyperparameter, which controls the rate at which the parameters are updated. Right? Then what you do is you iterate. You repeat the previous two steps, step 2 and 3, until a stopping criteria is reached or met. The stopping criteria could be a number of iterations, a fixed number of iterations, convergence of the cost or loss or error function, or reaching a predefined threshold for the gradient. So these could be, and you iterate till then. You converge. The gradient descent algorithm converges when reaches a point where the cost function has been minimized, the error function has been minimized, or when it cannot make any further improvement. So you reach a convergence. Now the final parameter of the model represents the optimized solution that minimizes the cost or the error function or the loss function, whatever words we want to use that. So a gradient descent is a fundamental optimization algorithm used not only in machine learning but also in various other optimization problems in mathematics, you know, and computer science. It forms the basis of more advanced optimization techniques like stochastic gradient descent, mini-batch gradient descent, Adams optimization, which were commonly used in training deep learning models, right? So that's what a gradient descent optimization process is. So what does how does learning rate in this gradient descent help us, right? So a higher learning rate, if you use in this whole process of the learning rate, can lead to a faster convergence. So you can reach to the convergence faster, but it may also cause the algorithm to overshoot the optimal solution because you're moving too fast. A lower learning rate may lead to slower convergence, but may result in more stable optimization process. Now, tuning this learning rate is crucial, is critical for optimizing the performance of the gradient descent based algorithm, optimization algorithm. So this is a critical parameter that helps you reach the optimization, and as we'll see later on, it avoids any kind of overshooting or undershooting. So what is next? So we will look at second hyperparameter that can be used in tuning the machine learning or deep learning models, which is number of hidden layers in the neural network. It is more used in deep learning models. So thank you so much for watching this eighth algorithm selection and development lecture. In this course, Master in Artificial Intelligence, I hope you're continuing to learn new things, continuing to enjoy. And I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions, and do download the PDF file to take a look at anything that you want to. And I do look forward to see you again, as I said earlier.